Hi friends, this is Persis. I did my master's in medical biotechnology, and this channel is about learning biochemistry. I love the subject so much, and in this video I want to explain you the formulas which we use regularly in the lab for making of the reagents. So if you take an assay, before setting up of the assay, we need to make the reagents. Reagents play a very key role in the success of an experiment. Even though you know the scientific background of the assay and you can set up the assay plan the assay very well, but if you fail in making good reagents, your assay is going to end as a fail. So it's very important to know how to make the reagents. So in making of the reagents, the formulas play a very key important role in making a good reagent. I've worked both in India and also in US in biology labs, and I would like to share some of my experiences how to make the reagents in the lab. Let's go. Let's dig into some formulas. The first one is percentages. I'll explain this with an example. So how do you make a 2% NaCl solution? So for this, what does the 2% NaCl solution means is we have to weigh 2 grams of NaCl and mix it in 100 ml of the solvent. Take solvent as water. So 2% NaCl solution means 2 grams of NaCl dissolved in 100 ml of water or any of the solvent. So generally during the lab, you may not need every time 100 ml of the 2% NaCl solution. So you need to know how much volume you really need for your everyday use. So for example, if you just need only 10 ml of the 2% NaCl solution, then you need to weight by 10 becomes 0.2 grams. So you need to know how much volume you need and accordingly weigh the amount and then make the solution. If you see the first and the second one, when you need only 10 ml and if you prepare 100 ml, you're gonna waste a lot of solute. So NaCl, it may not be an expensive solute, but there are some solutes, some compounds which are really expensive. So we need to be really mindful of how much volume we need. The next one is molarity. The formula for molarity is weight in grams by molecular weight of the solute or the compound into 1000 by volume in ml. You can get the molecular weight value on the bottle of the compound or the solute itself. For example, if you want to, and one more very important thing is when you're calculating the molarity of any biological compounds, you need to check whether it is a D form or L form or anhydrous form or hydrated form. So let's see how to make 1 molar glucose solution. A volume I need is 100 ml. I know that the molecular weight of glucose is 180. So just substitute. I want 1 molar solution, X by 180 into 1000 by 100. So it becomes X is equal to 180 into 100 by 1000. So it becomes 18 grams. So if you dissolve 18 grams of glucose in 100 ml of water, you may get 1 molar of solution. The third one is normality. Weight The formula of normality is weight by equivalent weight into 1000 by volume in ml. So the next one, which is very important one, is how to dilute a high concentration solution into a low concentration solution. The formula used is C1V1 is equal to C2V2. So if you have a high concentration solution, you can dilute it into a low concentration solution by using this formula. The C1 can be percentages, the C1 can be molarity, the C1 can be normality. For example, you have 1 molar glucose solution and you want to make 0.1 molar glucose solution, and the volume you need is 100 ml. So how much is the volume of the high concentration solution you need? Simple. Let's put all the values into the formula. Let's see, this becomes C1, this becomes the final concentration C2, and this is the volume V2. So 1 into X is equal to 0.1 into 100. So X becomes 10. So if you take 10 ml of 1 molar glucose solution and dilute it to 100 ml, it becomes 0.1 molar solution. And if you want to dilute from a very high concentration to a very low concentration, I always prefer to make an intermediate concentration to get a very accurate final concentration. So when you're going from very high to very low, there might be pipetting errors, so you may not get an accurate low concentration. So for example, if you have a 100 molar solution and you want to make a 1 molar solution, what I usually do is I just make 10 molar and from there I go to 1 molar. This is very important when you are doing with very high sensitive compounds. So, and one more thing is, when you are diluting cells, it is very important to go through an intermediate step to reach your final concentration. For example, you have a solution of 10,000 cells per ml and you want to make 100 cells per ml. So what I would do is, first I would do 1,000 cells per ml and from then I go to 100 cells per ml. And when you are dealing with cells, you need to be very gentle on pipetting because cells are very fragile. So by going through an intermediate step, you may reach an accurate low concentrations. I just wiped the board to make the new notes. So we have seen how to dilute from high concentration to the low concentration using the formula C1 V1 is equal to C2 V2. We really need to master this because we can use this to dilute any concentrations. It can be percentages, it can be molarities, or it can be normalities too, or it can be cells also. So it's very important to know how to use this formula and when to use this formula. And one more thing I forgot to mention during the percentages is that the weighing. It's very important that we need to check our weighing balance has been calibrated and it is in good working condition, because if you weigh it and it shows a wrong reading and it's gonna make a wrong read, like the concentration will be different as the weight will not be the accurate one. And one more thing is when we use the butter paper or wax paper, the weight of that for weighing the solute, the weight of that wax paper or the butter paper should be tared out. It is very important. Many times we forget to tear it because of the busyness in making the in carrying out the experiment, but it should be like a default step to do. So in our lab, wherever I worked, we have schedules where the weighing balance will be calibrated very now and then, almost like weekly, or depending upon the usage. If it is used more, it is more frequently calibrated. So it's very important to check your weighing balance when you do reagents. And the next one is ratios. So this is especially useful when you have kits. Like in the lab we use kits. It's most probably like for the detection reagents we use kits. So in the detection reagents, the company will not disclose us the percentage of the solution or the normality of the solution, like any concentration of the solution. They just gives the ratio. For example, for a detection reagent, they'll tell solution A, mix 5 ml. Solution B, mix 10 ml. Solution C, mix 5 ml for example, or 2 ml. So if you mix all the solutions, it will be 17 ml. So this would be the reagent. So we have to mix the different solutions in this different ratios so that we get a final volume of 17 ml. So for that day, for your assay, for your experiment, how much of the detection reagent you use? For example, if you want to make 170 ml for that day required for your use, so you have to add each solution correspondingly. Very important to mix the ratios accurately, and this is very often in any lab with most of the detection reagents. And one more thing is the detection, when you are making large volumes of the reagents, of the detection reagents, you need to give a 5 ml of dead volume, because then some solution will be lost during pipetting error. So you need to make plus 5 or 10 depending upon how you are pipetting, so that the dead volume, it will cancel out the dead volume and you'll have sufficient enough when you are working out with your assay. And one more thing is the detection reagent. When it comes to detection reagents, the detection reagents sometimes they are very temperature sensitive. So for your assay to work, they should be in the room temperature, but their storage conditions will be in 4 degrees. So it's always important to take them out from 4 degrees and keep it in the room temperatures, the required amounts, especially in the room temperatures. And some of the reagents are photosensitive. In my lab I used detection reagents which are photosensitive, so we used to wrap them with aluminum foil, or in some labs they keep in the dark place. Anything works. Whatever is your lab practice, we can follow that. And coming to your reagents, some of the solutes, like all the reagents what you need for your assays, we used to have a practice like we check the inventory and see which reagents are going low, and we need to maintain the inventory with sufficient at least for a couple of months, because I went through some situations where the reagent which I needed got back ordered, and it will affect our work. So it's always important that we need to maintain the inventory of the reagents and at least sufficient enough for a couple of months, depending upon your workflow. And what the practice we had in my working labs, so whatever practice I had in my when I was working in the labs was that we need to intimate my manager that this inventory is going low, so I need to order them. So everything was done so that we had the reagents on time to the sufficient level. And one more thing is we always need to check the expiry dates of the chemicals we have in the lab. It's very, very important, because if you work with an expired chemical, it may not give the results, the good results or the desired results, which means the assay is a fail, because the things were not working as they have to work the way they should. So we always need to check for the expiry of the chemical or the reagent. And one more thing what I have observed is like there are some very sensitive assays where the reagents which I use, they work a particular brand and works, the chemical of that particular brand only works for that assay. Usually it should not be the case, but for very sensitive assays, like I have experienced that some of the reagents, they do behave like that, like a particular brand works very well in that particular assay. The reason what I figured it out was that the extraction and the purification processes are different, maybe different for different brands. So there may be something which may be during the extraction process which might be hindering the reaction or the assay. So it's very like this was like I had this kind of issue in few of my assays. So but if the compound is 100% pure, you should not have any issue. So these are a few of my experiences I had working in my lab. So thank you, friends. And this video is mostly for biochemistry people who love biochemistry. Please share it with your biochemistry friends or people who need help with biochemistry. If you please like it, subscribe it and share it so that I can add more videos and we can learn more biochemistry with me. Thank you.